So we've been studying how to handle numbers and measurements. And so if you have a ruler like this that goes, let's see, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and you had something that was maybe right here, what would you put? Well, let's see. We've learned that goes up by tens, right? So the next decimal place down is the ones. So I'd say that's about 102 centimeters. Okay. That means the hundreds place was known, the tens place was known, even though it was a 0, and the ones place was guessed. That's 3 measured decimal places, or 3 significant figures. So that has 3 sig figs. Now, and it's plus or minus 1 centimeter. Okay, so there's 2 reasons we have to know both the uncertainty and the number of sig figs for this class. Because we're going to do math with measured numbers, and when you do math with measured numbers, you're going to have to be able to round off correctly. So I think we're pretty good as a class at understanding the uncertainty. If I had something like this, 12 days. Now, people might want to say 12 days, that's like exactly. Well, no, days is something that you measure. It's not something you can pick up and hold in your hand. It's very different than, for example, 12 pencils. Because 12 pencils actually has no error because you're holding 12 things. If you take these pens and you count them up, 1, 2, 3, there's not like you get to the last one and say, oh, gosh, is that a pen? No, it's not. You just don't do that. You say, I've got exactly 12 pencils. So 12 pencils and 12 days are very different things. 12 days is a measurement, and 12 pencils is what's called a counting number. If you're counting a relatively small number of easy things, then you say, oh, well, I don't have to worry about uncertainty because it's not uncertain. I'm counting things. Now, the 12 days, I can't hold a day in my hand, so that, even though I didn't write or see the device I measured with, I'm going to assume in this class that it's plus or minus 1 day, which is not a very accurate time measurement. But that's the rule. Whatever the last digit is, you say that's the errored or the decimal place that I'm guessing. So 12 days would have 2 sig figs. But what do you say about something that's exact? Well, in this class, we'll just say that's exact. And so I'm not going to worry about how many sig figs it is. Turns out the number of sig figs it is when it's exact is like infinity. It's 12.0000 forever. Okay? So you have to recognize when is something a measurement and when is something a counting number. Look at our next example. 3.00 hours. Okay? That 0 would not have been written in a math class, but it's in a science class because it implies plus or minus 0.01 hours. Okay? In science class, the last decimal place that is measured is the place that you guessed. So how many measured decimal places is that? Well, the ones place I know for sure. The tenths place and the hundreds place is implied to be measured, so I'd say that's 3 sig figs, and we'll just use 3 sig figs like that. Okay? How about this one? 0.002 kilograms. That's the next one. Okay? How would you do that? Well, let me talk about those zeros in front of the 2. So if you have something like this, if I had, back on this first ruler at the top, if I had that number, I'd say, oh, that's about 14 centimeters plus or minus 1 centimeter. I measured the tens and I measured the ones. Well, did I measure the hundreds? Yeah, it's out here, and there's a 0 in the hundreds. Well, I don't get to count the hundreds place because my measurement hasn't made it to that part of the ruler. So zeros in front of numbers don't make any sense. You wouldn't put a 0 there, it makes no sense. But if you have a 0 in front of this number, what that's implying is you have a ruler that went something like, here's the piece we're on, hundreds place, so that'd be like 0, and then the next line would be 0.01 and 0.02. Okay, and so what am I doing? If I know and this would be kilograms, if I know the hundredths place, then I'd be guessing the thousandths place. So that 0.002 kilograms is something down here, right? Well, if it's down there, I haven't made it to the hundredths place. So this 0 doesn't really count. It's just holding the 2 out where it goes. I also haven't made it to the tenths place, which would be way out here. So these zeros in front of numbers they're called decimal placeholders, and and they do not count as sig figs. So this only has one measured decimal place. So it's got one sig fig, and it's plus or minus 0.001 kilograms, because that's the last digit that was written down. Okay? How about the next example? 1,000 inches plus or minus 10 inches. Okay, now we've talked about numbers where there was zeros before. Okay, those are placeholders. What about these zeros? Well, unless I can see the ruler, I'm not sure which of those zeros is the last decimal place that counts. What they told me with this plus or minus 10 is that's the place that I guessed. Okay, that means I knew the hundreds, or sorry, the thousands. I knew the hundreds. I guessed the tens. So that would be 3 sig figs, because I measured 3 decimal places. How about this one? 0.00300 centimeters. Okay, this has that zeros before the number thing going on. Well, those, the tenths and the hundredths, they don't count because I haven't got there yet. The 3 counts. What about these trailing zeros? Well, they would not be there unless they were measured. So this implies that it's plus or minus 1 in that digit, plus or minus 0.00001. Did I do that right? 1, 2, 3, 4, the 5th place. 1, 2, 3, 4, 5. Okay? This implies that 0 down there, that it's plus or minus 1 in that decimal place. So that means I measured the 3, I measured that 0, and I measured that 0. That would be 3 sig figs. In this class, there's a couple ways you can handle these zeros over here. They're the most confusing ones. For example, this one. If I don't see the ruler, this 200 could have been this. It could have been 100, 200, 300, and it could have been right there. If it was right there, I would say, oh, it looks like it's right on the 200. Well, wait a second. This ruler is plus or minus 10, because these would be 10, 20, 30, 40. So that would be 2 sig figs. And only that 0 would count. What if it was a ruler like this, where it went 199, 200, 201, 202. Well, let's see, if it was right there, this ruler would be, it's going by the ones place. Then the tenths place would matter, and I would need a 0.0. Okay, so that's not confusing. Okay, if it was this, well, if it had a situation where it was going up by the tens, so 190, 200, 210, if it was right there, then let's see, I've got the ones place for sure, or at least I'm guessing it, then that 0 would count. So without the rulers, how do I know which of those zeros is the last measured decimal place? Well, in this class, if we want the ones place to count, we'll put a decimal point. That will imply plus or minus 1 centimeter, and that would make the hundreds, tens, and ones place all measured. That's 3 sig figs. Okay, how about the second to last example? Here's another situation, 33200 centimeters, where I can't tell which is the last measured place. It could have been this 2, could have been that 0, or it could have been that 0 in the ones place. So what if it was plus or minus 10? Well, rather than writing plus or minus 10, sometimes we'll just put a line under that 0 to say that 0 there means it was measured, and that'll be a shorthand for writing plus or minus 10 centimeters, because the plus or minus 10 means that 0 was the decimal place that was guessed. This final 0 is just a placeholder, so it doesn't count as a measured decimal place. So in this case, we'd say 1, 2, 3, 4 sig figs. 4 measured places, sig figs, and plus or minus 10. The last one just says 200 centimeters. Okay, that's the one that's hard, because I can't tell the answer. As we look at these rulers over here, I'm not sure if it came from this ruler or if it came from this ruler. If it came from this ruler that went up by hundreds, then that 0 is the last one. If it came from this ruler that went up by tens, then that 0 is the last one. Or if it came from a ruler like this, 10,000. Oh, sorry.